Let's try another example. In this problem, the direct substitution of this limit gives e to the infinity, which is infinity, divided by infinity squared, which is also infinity, and we see that we have an indeterminate fraction of infinity over infinity, meaning we can use L'Hopital's rule, taking the derivative of the top function, we get e to the x. Taking the derivative of the bottom function, we get 2x using power rule. This limit is still indeterminate of type infinity over infinity, so we can apply L'Hopital's rule again. The derivative of the top function is e to the x. The derivative of the bottom function is 2. Now we no longer have an indeterminate fraction. E to the infinity is a very large number. Dividing it by 2 is still a large number, and the limit is infinity. Our next example, we have the limit as x approaches infinity of the ln of x over the square root of x. Trying direct substitution, we know the ln of x function looks like that, and the square root of x function looks like that. So both functions are increasing to the right, so we have a limit that's infinity over infinity. Since this is indeterminate form of this type, we may use L'Hopital's rule, and the derivative of the top is 1 over x. The derivative of the bottom, which we change to x to the 1/2 power, is 1/2 x to the negative 1/2 power. At this point, we could try direct substitution again, but it's not advisable since it would result in 0 over 0. However, we can use algebra to simplify this limit. The top is x to the negative 1, the bottom is x to the negative 1/2 divided by 2. So this gives us x to the negative 1 plus 1/2 all times 2, which is the same as 2 divided by x to the 1/2. As x approaches infinity, the top remains a constant, the bottom grows large, and this limit goes to 0.